All right, welcome back to Sudoku After Dark. This is the series where I solve Sudokus and kind of just a more relaxed, take our time, that kind of stuff. And I've got a series of puzzles today, actually. These are by Michael Lefkowitz, and he calls them Beginner's Guide to Variant Sudokus. And there are actually 8 smaller puzzles. I think most of them are 4x4s. One might be a 6x6, and basically each puzzle is a different variant. So if you're newer to Sudoku variants, this would be a perfect series for you. And I actually recently posted over on my puzzle blog some easier introduction type puzzles for some variants, but they're full 9x9 puzzles. So link in the description if you're interested in those. But I'm going to solve Michael's puzzles today. We're just going to go through all 8 of them in order. And the links are in the description to where you can find all of these puzzles, of course, too. And so our rules are normal Sudoku rules, which on a 4x4 grid means you're doing the digits 1 to 4 in every row and column and 2x2 box. For killer Sudoku, we have these cages in the grid, and the digits in the cage sum to the number in the corner. So these 2 sum to 4, these 3 sum to 8, etc. Digits cannot repeat in a killer cage, so basically these 2 cannot be the same, even though by normal Sudoku they'd be allowed to be the same. Little killer is the digit outside the grid here, and it tells us that the digits on that diagonal sum to that number given outside, and digits are allowed to repeat on a little killer, so these could potentially be the same. That's all our rules. I'm going to give it a try right now. So we know that 4 and 2, if you think about it, there's only 2 ways you can do it. You can do a 1 and a 3 or 2 2s. Well, we can't put 2 2s in the same column, so this has to be a 1 and a 3. 5 can be 1 4 or 2 3. So we don't know that yet. 8 has to have a 1. Could be 1 2 5 or 1 3 4. But one thing that's interesting, so this is a good trick for killer Sudoku. Think about the totals for a row, column, a box. So we have the digits 1 through 4. 1 2 3 4. Every row is going to have the digits 1 2 3 4. Every column is going to have the digits 1 2 3 4. If you add 1 2 3 and 4, you will get 10. So every row, the total is going to equal 10. Every column, the total is going to equal 10. Every box, the total is going to equal 10. On a 9x9 Sudoku, that total is 45. But on this puzzle, the total is 10. So this being 5, these 2 have to be 10 minus 5, which is also 5. So these 2 sum to 5. Therefore, the total cage is 8. If these 2 are 5, this is 8 minus 5, which has to be 3. That has to be a 3. We don't know what these digits are yet, but we know they sum to 5. In fact, now we do. But that 3 makes this a 1 and a 3. And in fact, this 3 and this 3 both, because we can't repeat a digit in a cage, rule out 2 3 as an option for the 5 in these 2. These 2 sum to 5. That's either 1 4 or 2 3. And it can't be 2 3 for 2 reasons. So this is a 1 4 pair, meaning these are 2 3. Now, in this row, we've got a 1 and a 4. We've got a 3. This has to be the 2. Up here, we need 1 and 4. And we already have the 1 there, so this will be 4 and 1. We need a 2 for the column. This 3 makes that a 2 and a 3. And this row needs a 2 and a 4 still, and there's the 2 there, so that's the 4. This is the 2. We need a 3 for the column. And now we need 1 and 4 for the row. And normally this would be a problem. right? We have the 1, 4 here, the 1, 4 here. They could go either direction. But our little killer is going to fix that for us because 3 and 4 is 7. We need 8 total. So this has to be the 1 fixing the rest of those digits. And there we go. That is our introduction to killer Sudoku. All right, and our next puzzle is an introduction to Cropki. And so the way Cropki works is, again, we have normal Sudoku rules, 1 to 4 in every row, column, and box. A white dot separates digits that are consecutive. It could be 1, 2, 2, 3, 3, 4, etc. We could not put a 1 and a 4 in there. These digits have to be consecutive. Another way to say that is 1 is exactly 1 greater than the other. The black dots separate digits that have a 1 to 2 ratio. So in a larger puzzle, you could put, for example, a 3 and a 6, or a 4 and an 8. You could also do a 1 and a 2. A 1 and a 2 can actually be on a white dot or a black dot. And in this puzzle, not all of the dots are given. Sometimes you'll have a puzzle where all dots are given and you can't have consecutive digits or 1 to 2 ratio that don't have a dot. But that's one doesn't apply to that. So link in the description, and I'm going to try it myself. So in a 4x4 puzzle, the black dots are going to be very restricted because you can only have 1 and 2 or 2 and 4. You can't put a 3 on a black dot, and there has to be a 2 on a black dot. So we know there's a 2 on both of the black dots because it's either 1 with 2 or 2 with 4. So interestingly, what that does for us here is there's a 2 here and there's a 2 here, which means you can't have a 2 in either of those cells in that column or in either of these cells in that row. So you can't put a 2 in any of these cells in this box, which means we get a 2 right there, telling us this is either 1 or 3 because it has to be consecutive. Now, we don't know which one that is, but what we do know is that the 4 in this box has to be in one of these two cells. And if the 4 is in one of these two cells, it is not in either of these cells. Therefore, this cannot be 2 and 4. It must be 1 and 2. Now, using that same logic, the column then requires that these are 3 and 4. And now the box, in this box, the 3 and the 4 have to go there. This has to be the 1. Now we can do the same thing using the 1 here, saying that this has to be 2 and 4. It can't be 1 and 2. Now that 4 makes this a 3 and a 4. Very nice. Okay, now we've got 3 and 4 down here. We've got 1 and 3 up here because of the row. And 3 and 4 tells us that this is either 2, 3, or 4. Unfortunately, we can't limit it more than that. But this is interesting too. This is another good. I'm gonna get rid of that for a second. I don't think that's super helpful right now. But an interesting thing to look at here is this white dot. So white dot in a 4x4 grid is pretty limited, right? We can have 1 and 2. We could have 2 and 3. Or we could have 3 and 4. Those are the only options. Now, if you were to put 1 and 2 here, is that a problem? Well, it is, because we already know that this cell is 1 or 2. So we now have 3 cells in this row that are all 1 or 2, which is impossible. So we can't do 1 or 2. Now, similarly, if you did 3 and 4 in here, you have the same problem. You have 3 cells in the row that are 3 or 4, which is, again, impossible. So the only option we can put on here is 2 and 3, which is very interesting. It gives us the 4 and the 1 and the 2 and the 3. And now this 3 has to have a 2 or a 4, and it obviously can't be the 2 because it's in the row. It's also in the box already. So this is a 4, leaving us a 1 for the row. That 1 will give us the 3 and the 1, and the 3 will give us the 2 and the 3, and you can use the 4 or the 2 to get the 2 and the 4. Very cool. I liked that a lot. That was a really good puzzle. And now we are moving on to an introduction to XV. These are a lot of fun as well. Similar to Cropki in some ways, but a little different. So normal Sudoku rules. On this puzzle, we actually have a 6x6. We're putting the digits 1 to 6 in every row, column, and 2x3 box. And I suspect it's 1 to 6 so that we can include the X's. But the way XV works is cells separated by a V have to sum to 5, because of course V is the Roman numeral for 5. And an X separates digits that sum to 10, because X is the Roman numeral for 10. And if you wonder why I commented about 6 because of the X, just think about what you would put on an X in a 4x4 Sudoku grid. And that's all the rules. So I'm actually going to start with the X's, because in a 6x6, you can only go up to the digits 6 is the biggest you can put in there. So the only way you can make 10 in 2 digits is 4 and 6, or 5 and 5. But we can't put 2 5s in the same column. And so these X's are all 4 and 6. So then we can look at the V's. In fact, we can look at this V right here. The options on a V, they have to sum to 5. Sort of like we talked about with the killer Sudoku. The options are 1 and 4 or 2 and 3. So you cannot put a 6 on a V. So this has to be 4 with 1, giving us the 6 there. That 4 makes this 6 and 4. Now, the other thing that you can use, so we get the 4 and 1 there, but we also know that the 4 cannot be there or there. So those are both going to have to be 2 and 3, because the 4 is already ruled out in the column. This one is ruled out, the 4 is ruled out in 2 ways, 2 places, in both places. So this can't be 4, 1. This could be a 1, but that can't be a 4. And in fact, you can use the fact that these both point at that one. The fact that the 4 and the 1 are both ruled out of this spot, it doesn't even matter. This 4 wouldn't even have to be here. The 4, 1 here would eliminate 4 and 1 as possibilities on that V. In the same way, the 2, 3 here, pointing down there in the column, since you can't put a 2 or a 3 in this cell, you can't put 2 and 3 on the V. So those are 4 and 1. And the 4 and 1 there give us the order of those. Now in this column, we're only missing the 5. Okay, let's see the 2. Okay, in the box here, we have 1 of 2 or 3. We need the other one, and we also need a 6. But this cell can't be 2 or 3 because of the column. So this has to be the 6, and this is the other of the 2, 3. And we need, similarly, in this box, we need the other 2, 3 and a 5. But again, the 2, 3 can't be there, so that has to be the 5. And this is the other of the 2, 3. This 6 and this 6 both give us the 4 and the 6. We need a 1 for the row. Okay. Let's see, maybe we'll look at the column here. We have 1, 2, 3, and 4. We need 5 and 6, and the 6 is there. We need 1 and 4 for this column. The 3 there, that's been there for a while. If this wasn't the calm, relaxed Sudoku after dark, people might have been yelling at their screens, but of course that wouldn't happen. In this row, we need the other of the 1 and 4, and we have the 1 there. So that gives us the 4 and the 1 and the 4. We need 1 and 5 for this column, and we have the 1 there. So this is the 5 and the 1, leaving a 5 for the box and the row. For this box / row, we need 2 and 5, and we have the 5 up there. We need 1 and 6 for this row, and we have the 1 and the 6 up above. And finally, we get the 3 and the 2. And there we go. That is XV Sudoku. Very nice. And now we're moving on to introduction to arrows. Again, we have the digits 1 to 4 in every row, column, and 2 by 2 box. The way the arrows work is the sum of the digits on the line part of the arrow equals the digit in the circle part of the arrow. So these two together sum to this number. Now, Michael has done a good job here because we have a sort of standard arrow, a circle with multiple cells on the line. We also have a couple of unique situations that show up often in arrow Sudoku. We have one here. Now, it works the same way, but if you think about the digit on the line, the digits on the line sum to the digit in the circle. Well, the only digits on the line is this one here. It's the only digit on the line. Therefore, this digit sums with itself, with nothing, to this digit. So effectively, these are the same digit, is what I'm saying. Now, up here, we have this interesting looking thing. It's often called a pill shape. Some people call it an oval. It's not really an oval. Michael actually calls it an oblong, which I don't know how many people are familiar with that term, but that's what this is. But essentially, the sum for the digits on the arrow here equal the digits in the oblong or pill, and they're read as a 2-digit number left to right. So if you had a 1 and a 2 here, that would say 12. These 3 digits would sum to 12. And that's all we need to know. So I'm going to give it a shot now. Let's start with this bigger one, because these 3, now digits are allowed to repeat on an arrow if allowed by other Sudoku rules. Like these 2 can't repeat, obviously. So the minimum we could put in here would be 1, 1, and 1, which would be 3. But maybe the other thing to think about is what's the minimum this total can be, because this can't be a 0. There's no zeros in the grid. So we could do 1. We can't do 11 because it would be repeating the 1. So 12 is the minimum we can do. And what's the maximum these can be? Well, 4 is the largest number in the grid since it's a 4 by 4. So 4, 4, 4, that equals 12. So in fact, those are going to have to be 4s. This is going to have to be a 12. And now we need a 3 for the row. We need a 3 for this box. These are 1 and 2. We need a 2 for the column. These are 1 and 3. And we know that these 2 digits are the same, as we discussed. So this is a 1 or a 3, meaning that in this row, we're just missing the 2. That 2 makes this a 1 and a 2. 1 plus 2 is 3. So we get 1, 3, 1, and we just have a 4 to finish off the puzzle. Very nice, very nice. And now on to introduction to anti-night. So anti-night is an interesting one because we don't actually get any clues in the grid. There's no dots or V's or cages or things like this. It's just sort of a rule that applies to the whole puzzle. But if you're familiar with how a knight moves in chess, that's what we're talking about here. So digits that are a knight's move, a chess knight's move, apart cannot be the same. So let's color this one. We'll make it that color. I'm not going to say what color that is because I am colorblind and I will be wrong. But you know what color that is, unless you're also colorblind. But the point is, if you think of the way a knight moves in chess, it's sort of this L shape. It's 1 space in one direction and then 2 in another direction. It could go this way, something like that. And so this cell, whatever this digit is in this cell, it cannot be the same digit as this one, this one, this one, or that one, because those are all a chess knight's move away. And that applies to every cell in the grid. None of them can be the same as a cell, a chess knight's move away. We also have some Cropki dots. Remember, you may remember that from the previous puzzles. The white dot separates consecutive digits. The black dot separates digits that have a 1 to 2 ratio. Let's see. There's a few ways we can start this actually, but the white dot is very limited by the 3. So you may remember that for consecutive digits in a 4x4 grid, we have 3 options. 1, 2, 2, 3, 3, 4. Well, 2, 3, and 3, 4 both would require a 3 to be on this dot. So this must be 1 and a 2, leaving a 4 for the row. The other thing we can look at is the 3. So we know these are 3 and 4, but these two are a chess knight's move apart. You can go either direction here, but either way, this one cannot be a 3. It's a 4. That gives us the 3 there. These are 1 and 2. Now, the black dot here, if this is either 1, 2, or 2, 4, but if it was 1, 2, we would have no place to put a 4 in this column. You could also say we have 3 cells that have to be 1 and 2. Either way, it doesn't work. These must be 2 and 4, giving us a 1 and a 2 there. These are 1 and 3. And again, this one sees that one by the knight's move. And so this must be the 1 and the 3. Similarly, this cell actually sees 4s in 2 different places by knight's move. So it is doubly not a 4. Get a 2 and a 4. These are 3 and 4 for the row. And we have the 3 and the 4 there. These are 1 and 2. And there's 2 ways we can fix these this deadly pattern, as it's called. We could use this one, which sees that cell by knight's move. Also, this one sees that cell by knight's move. So I guess there's more than 2 ways. There's quite a few ways. In fact, these ones both see that one. This 2 sees that cell. This 2 sees that cell. This 2 sees that cell. This 1 sees that cell. So there are several ways you can distinguish these last digits, but I am going to just fill them in. You can pick your favorite way to see that, but there we go. That is how knight's move works. Okay, and now on to introduction to thermometers. The way thermometers work is the digits on a thermometer must increase moving away from the bulb and towards the tip. They don't have to be consecutive. You don't have to do 1, 2, 3. You could do 1, 3, 4. You could do 1, 2, 4. You could do a lot of things. They don't have to be consecutive. They just have to increase. You couldn't go 2, 1, for example. And that is all we need to know. So there's a few ways we can do this. Especially if you're newer to thermometers, a good method is to put in the pencil marks, the options. So we know this could be a 1, right? Obviously, well, these are going to be the same, so we could actually do that. But we know these could be 1, but what's the maximum they could be? Well, to get the maximum, you got to start at the end and work backwards. So the max this could be is 4. So the max this could be is 3. The max this could be is 2. And similarly, to get the minimums, you can start here and say the minimum this can be is 1, the minimum this can be is 2, the minimum this can be is 3. So we're going to get 1, 2, 2, 3, 3, 4 as our options. Now, this 2, 3, and this is where the pencil marking is often helpful with thermometers. We have 2 cells in this row that must be a 2 or a 3. Therefore, they are the 2 cells that are a 2 and a 3. We just don't know which one is which yet. Leaving 1 and 4 for the row. Now, this cell, can this be a 4? Well, this one would have to be something bigger. And there's nothing bigger than 4 in a 4x4 grid. So this actually must be the 1. This must be the 4. Now, that 4 tells us that this is a 3, 2, and 1, leaving a 4 for the column. This 1 tells us this is a 2, 3, 4, leaving 1 for the column. Now, these didn't have to be consecutive digits. They ended up being consecutive digits, but they didn't have to be. For this box, we're missing the 4. For this box, we're missing the 1. You'll note this one was not consecutive. It was 1 and 4. We have 2 and 3 left for the column and the box, and they must be in order because of the thermometer, leaving a 3 for the row and a 2 to finish the puzzle. There we go. Very nice. And now on to Renban lines. These are interesting. So we have the normal Sudoku rules again, 1 to 4 in every row, column, 2 by 2 box. These purple lines are what are called Renban lines. Now, a Renban line contains a set of consecutive non-repeating digits, but they can be in any order. So this could be 1, 2, and 3. It could be 2, 3, and 4. It cannot be 1, 2, and 4, or 1, 3, and 4. They do not have to be in order. You could do 1, 2, 3. You could also do 1, 3, 2, or 2, 1, 3. They don't have to be in order, but they do have to be consecutive and not repeat. So I think one thing to think about is this longer Renban. Well, it's 4 cells. In a 4x4 grid, that's going to have 1, 2, 3, and 4. So it has to have, importantly, a 2, because there's a 2 here. Now, this digit can't be the same as that one, can't be the same as that one. It can't be the same as this one. So where are you going to put a 2 on that line? It must be here. Now, we know that these are 1, 3, and 4, but we don't know which one is which at this point. So let's move on to the 3 cell arrows. Now, what are your options there? Well, it could be 1, 2, 3, or it could be 2, 3, 4. Those are your only options. Either way, they must have a 2 and a 3. It's 1, 2, 3, or 2, 3, 4. So it's 2 and a 3 with either a 1 or a 4. Well, if you're going to put a 2 on this line, and you have this 2 here looking at those in the row, this must be the 2. And now where can you put a 2 on this line? It can't be here. It must be there. So we get all of our 2s. Now, this is either 1, 3, or 3, 4. Either way, we know there is a 3 in one of these 2 cells, meaning this can't be a 3. So where do you put the 3 on this line? It must be there. This is 1 or 4. This is 1 or 4. This is 1 or 4. Now, if it's 1, this has to be 2, because these have to be consecutive, essentially. A 2-cell Renban is much like a white Cropki dot. They're just consecutive digits. This is 1. This would have to be 2. It cannot be a 2 for several reasons. Therefore, this is a 4, making this a 3. That 4 makes this a 1. We now know these are 3 and 4, leaving a 1 for the box. We also could have said you only need a 1 for the column. This 1 makes that a 4. We need a 1 for the box and the row. We need a 1 for the column. These are 3 and 4, but we already have a 4 on the line, so this must be 3 and 4, and that gives us the 3 and the 4 over here. And now on to counting circles. These are pretty interesting, I think. A little bit different than some of the other constraints. So again, digits 1 to 4 in every row, column, 2 by 2 box. The way counting circles work is any digit in a circle indicates how many circles contain that digit. So if there's a 2 in this circle, it means there are 2 circles in the grid that contain a 2. It must be exactly 2. We can't have just the 1. We can't have 3 or 4 or 5. It must be 2 circles that contain a 2. If you have a 1 in a circle somewhere, that must be the only circle that contains a 1. That is all we have for rules. So I think the first thing to do on a counting circles puzzle is to count the circles. It seems kind of obvious, but we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. So similar, my brain thinks of it similar to killer Sudoku in a way. We know that you can't have like two circles with 2s and then another 2 circles with 2s, because you'd have 4 circles with 2s. So sort of like how in a killer cage you can't repeat a digit, we can't really repeat a set of circles, if that makes sense. Once you've got 2 circles with 2s, wherever they are, those are the only 2 circles with 2s. So knowing we need to get to 9, and we need to have unique digits summing to 9, what are the ways we could do it? Well, we only have the digits 1 to 4. So in a bigger grid, you could do 1, 2, and 6. You could do 1, 3, and 5, but we don't have a 5 or a 6. So I believe the only way to get to 9 with the digits 1, 2, 3, and 4 without repeating a digit is 2, 3, and 4. You can't do 4 and 5. You can't do 3 and 6. Some of these other ways that you might normally get to 9 in a bigger grid, we have to have 2, 3, and 4. So therefore, there will be 2 circles with 2s, 3 circles with 3s, and 4 circles with 4s. There will be no circles with 1s. So we can do a couple things with that. First of all, we can look at this box and say, well, 3 of the 4 cells have circles. Same down here. Since we know that we can't put a 1 in a circle, the 1s must not be on the circles. Same with this row. This must be a 1, giving us the last one. So we get all the 1s easily. Now, the 2, 3, and 4 is a little bit trickier, but I think 4 is the place to start because we know we need to have 4 circles with 4s. Well, there's only 4 4s in the entire grid, so all of the 4s in the grid must be on circles. So in this box, or maybe this box down here is a better place to look. Where can we put a 4 in this box? It must be on the circle. It must be here. That's going to rule the 4 out of these. This is a 4. It puts a 4 up there. Now, in this box, we know it must be on a circle, so it has to be down here. Now, this 4 actually tells us where it is. But even before we did that, we knew that the 4 had to be in one of these circles, meaning this couldn't be a 4. But the 4 is there and there. Next up, let's think about the 3, because again, we need 3 3s on circles. Well, we have no more circles in this box. So we have 3 boxes with circles, and we need 3 3s on a circle. So in these 3 boxes, the 3s must be on a circle. This is the only place left in this box for a circle. That makes 2 for the row. This is a 3. Makes 2 for the column, 3, and now we're just filling in the remaining digits. We need a 2 and a 3 down here, and there we go. Counting circles, very interesting. And that will bring us to the end of the Beginner's Guide to Variant Sudokus by Michael Lefkowitz. So if you were unfamiliar with some of these constraints, hopefully this helped you learn about them. Let me know in the comments which is your favorite constraint. And of course, thank you to Michael for making this set of puzzles. If you tried them out, let me know how it went for you. And if you were just following along with me, let me know if there were some that were confusing or you had questions on. And of course, as always, be sure to subscribe for more.